August 1st, 2012. Jersey City, New Jersey. The sun is coming up over a glass tower on the Hudson, directly across the water from Wall Street. Inside that tower is Knight Capital. You've probably never heard of them. But if you bought a share of anything in America back then, there's a good chance Knight was the machine on the other side of your trade. Think about that. Roughly 1 in 6 of all shares traded in American stocks flowed through this one building, day in, day out. It is 8:01 in the morning. The market opens in 89 minutes. And somewhere inside Knight's own systems, the first warning email has already been sent. Nobody reads it. Nobody reads the next 96 either. By 10:15 that morning, this company will have lost $460 million. Not in a market crash, not to a rogue trader. In 45 minutes, on autopilot. Here's the part that makes this story special. The code that destroyed Knight Capital wasn't new code. Nobody wrote a bug that week. The killer was a feature that had been switched off since 2003. Dead code. 8 years in the grave. And on that Wednesday morning, one reused flag woke it up. This is the story of the most expensive deploy in software history. 8 servers, 7 updates, and one machine that never got the memo. And stay with me, because the detail that hurts the most isn't the bug. It's the 97 warnings that landed in inboxes before the opening bell. We'll get there. By the end of this video, you'll know exactly how a forgotten if statement can eat a Wall Street firm in less time than a lunch break. And you'll never look at your own deploy pipeline the same way. So how does a company lose $10 million a minute? To get that, you need to see what Knight actually did all day. Because their whole business was speed. Knight was what's called a market maker, the middleman of the stock market. And in 2012, they were not just any middleman. They were the biggest one in American retail stocks. When you tap buy on your broker's website, E-Trade, TD Ameritrade, Scottrade, your order didn't go to some guy in a pit shouting numbers. It went to a machine, very often a Knight machine, sitting in New Jersey. The deal works like this. The market maker stands in the middle and quotes 2 prices all day on thousands of stocks. I'll buy from anyone at this price. I'll sell to anyone at that slightly higher price. The gap between those 2 numbers is called the spread. Fractions of a penny, usually. That's the fee for always being there. Always willing to trade, in both directions, instantly. Fractions of a penny sound like nothing. Now multiply by volume. In 2011 and 2012, Knight's trading accounted for roughly 1 out of every 6 shares changing hands in American-listed stocks. Their systems routinely handled a double-digit share of the entire market, day after day. You don't do that with people on phones. You do it with software. Racks of it, tuned for microseconds, sitting as close to the exchanges as physics allows. And that's the deal Knight made. The same deal every high-frequency firm makes. The machines print fractions of pennies millions of times a day, as long as the machines are right. But when the machines are wrong, the same speed just runs in reverse. The engine doesn't care which direction it's compounding. The heart of Knight's operation was a system called SMARS, the Smart Market Access Routing System. A router, but for money. SMARS had one job. Take a big incoming order, the parent, slice it into smaller child orders, and fire those children at the exchanges fast until the parent is filled. Parent comes in, buy 100,000 shares. Children go out, 1,000 here, 5,000 there, wherever the price is best. When the running total hits 100,000, stop. Keep your eye on that last word. Stop. The entire safety of this system lives in one question. Does the router know when it's done? It's such a boring question. It's the kind of thing you'd never put on a slide. And it is exactly where a 17-year-old company was about to bleed out. Hold that thought. Because in 2012, on one specific server, the answer was about to become no. One more piece of context, because the irony is almost unfair. 10 weeks earlier, in May 2012, NASDAQ systems had glitched during the Facebook IPO, and Knight, caught in someone else's software failure, ate a loss of around $35 million. Knight's CEO went on TV and criticized how that mess was handled. The company knew, better than almost anyone on Wall Street, what broken trading software could do. They had seen the monster. They just assumed it lived in other people's data centers. Now let me take you to the room where this actually happened. Not a trading floor. No screaming, no jackets with badges. A server room. Cold air, white noise, blinking lights. SMARS ran on 8 production servers. 8 identical machines, splitting the incoming order flow between them. Any order could land on any server. That's the whole point. They're supposed to be interchangeable. In the last week of July 2012, Knight had a deadline. The New York Stock Exchange was launching something called the Retail Liquidity Program, RLP, going live August 1st. Knight wanted in from day one. That meant getting new code into SMARS on all 8 servers in 4 days. So, starting July 27th, a technician rolled the update out the careful way, in stages, a few servers at a time, on successive days. 7 machines got the new code. The 8th one didn't. No error message. No failed checksum. No red light. Deployment in 2012, at one of the biggest trading firms on Earth, was a person copying code to machines. And one copy to one machine just didn't happen. And here's the institutional part, straight from the SEC's report. Nobody double-checked the deployment. Not because someone was lazy, because no procedure said anyone had to. No written checklist. No second technician reviewing. No automated job comparing what runs where. The report says it flatly. No one at Knight realized the code was missing. 7 green lights. 1 silent machine, still carrying its 2003 cargo. Nothing about this looked like a catastrophe yet. It looked like a Tuesday. To see why that missed server was a bomb and not a hiccup, we need to open the code and meet a ghost. Years earlier, SMARS had a feature called Power Peg, a specific strategy for working big orders, pegged to the market price. Knight stopped using it in 2003. But here's the thing about trading systems, about most production systems, honestly. Features don't get deleted. They get abandoned. Deleting code feels dangerous. What if something still depends on it? Leaving it feels free. So PowerPeg's code stayed right there, buried inside SMARS. Compiled in. Callable. For 8 years, the only thing keeping it asleep was a single flag that nobody said anymore. You probably see where this is going, but I promise it's worse than you think. Fast forward to July 2012. The developers are building the new RLP feature, and they need a per-order switch to turn it on. A flag. And instead of creating a fresh one, they reuse the old PowerPeg flag. Same field in the order message. New meaning. The plan was reasonable on paper. Delete PowerPeg, then recycle its flag. Flag says yes, you get RLP. Old meaning gone, new meaning in. Clean. Saves space in the protocol. On 7 servers, that's exactly what happened. PowerPeg deleted, RLP installed, flag rewired. But on server number 8, the delete never arrived. On that machine, the flag still meant what it meant in 2003. Wake up PowerPeg. Same message, same bit. On the server next door, it means a routine retail order. Here, it means dig up a 9-year-old trading strategy that no living config remembers. Now, even a zombie feature shouldn't be lethal, right? PowerPeg used to work. For years, it traded real money safely. Because it had a safety, a cumulative quantity counter. Count the fills, compare to the parent order, stop when you're done. The stop condition we talked about. Except, in 2005, during a refactor, Knight moved that counting step somewhere earlier in the SMARS pipeline. Out of PowerPeg, the feature kept its trigger and quietly lost its brakes. Nobody retested PowerPeg after that move. Why would they? It was dead code. You don't crash test a car that's up on blocks in the garage. Let that sink in. For 7 years, a loaded weapon was riding inside SMARS, on every single server. Trigger intact, safety removed, and everyone had simply forgotten it was there. One missed copy, one recycled flag, one safety check quietly relocated 7 years earlier. 3 small decisions, made in 3 different years, by people who never sat in the same meeting, snapping together into one perfect chain. Now, all it needed was traffic. August 1st, 2012, 9:30 a.m. Eastern. The opening bell rings on the New York Stock Exchange, and the retail liquidity program goes live for the very first time. Retail orders start flowing. Brokers tag them with a new flag. Yes, route them through SMARS. 7 servers read that flag and do exactly what they were built to do. Slice, route, fill, stop. And then there's Server 8. Server 8 reads yes, and here's an order from 2003. Inside Server 8, the resurrected power peg does the only thing it knows. Take the parent order. Firechild orders at the market. 1,000 shares. Another 1,000. Another. The fills come back, and here's the fatal beat. Nothing counts them. The cumulative quantity check, the stop condition, isn't there anymore. It moved in 2005, remember? So as far as this code is concerned, the parent order is never, ever done. Buy. Filled. Buy. Filled. Buy. A loop with no exit, running at machine speed, with real money. And the cruelest detail, another part of Knight's own system did know the parents were filled. It just had no way to tell SMARS. The information existed, one system over. There was simply no wire between the system that knew and the system that acted. 212. That's how many ordinary customer orders hit that server with the flag set that morning. 212 parents that could not die. Picture what a single one of those looks like. A retail customer somewhere wants, say, a few $1,000s of a mid-cap stock. A completely unremarkable Wednesday morning order. It lands on Server 8 and becomes an immortal machine gun. From those 212, Server 8 fired millions of child orders into the market. In 45 minutes, over 4 million executions in 154 stocks for more than 397 million shares. 397 million shares. For scale, that's like buying and selling the entire float of a decent-sized public company before your second coffee. At times, Knight's runaway orders were more than half the trading volume in these names. One confused machine, moving markets by itself. Traders across Wall Street watched these charts and assumed someone, somewhere, knew something they didn't. Nobody did. It was a wild loop. And the trades weren't just big. They were systematically terrible. The loop kept crossing the spread, buying at the ask, selling at the bid, paying the middleman's toll every single round. The exact opposite of Knight's own business model. Executed millions of times, as fast as the exchanges could confirm. A market maker earns the spread. Knight's zombie was donating it to its competitors at maximum possible speed. 10 seconds of this is a bad day. 45 minutes is extinction. So the obvious question, the one you're probably shouting at the screen, where was the off switch? Here's the answer, and it still shocks engineers a decade later. There wasn't one. No kill switch. No big red button. No documented procedure for, our own router has gone rogue, make it stop. Knight's people had to debug a live system, while it was setting money on fire at roughly $10 million a minute. Put yourself in that war room. It's 9:34. Alarms from the exchange side. Phone starting to ring. 140 stocks moving strangely, and your firm's name is on the volume. The New York Stock Exchange notices almost immediately. Unusual prints, strange volume, all tracing back to Knight. Within minutes, people outside the building know something is wrong inside it. You know it's you. You don't know why. And your instruments are lying to you by omission. Nothing was deployed this morning. The rollout finished yesterday. 7 servers report the new code, running clean. The dashboards don't show a bug. They show volume. There's no stack trace. No crash. No red box saying power peg has risen from the grave. The failure looks exactly like a very, very busy morning. Minutes pass, and every single minute, roughly $10 million. That's a kind of pressure most engineers will never feel, thankfully. So the team makes the reasonable call. The awful, reasonable call. What changed recently? The RLP code. It's the newest thing in the building. Suspect number 1. Roll it back. At roughly 9:58, 28 minutes in, they uninstall the new code from the 7 healthy servers. Think about what that means on server 8's terms. Nothing. It never had the new code. But on the other 7, the rollback resurrects the same 2003 pathway. Now the flag means power peg everywhere. They took the 1 server problem and made it an 8 server problem while trying to fix it. The SEC's wording is brutal. Quote, "This action worsened the problem." End quote. It's the deep trap of incident response. Roll back the newest change is the safest move 99 times out of 100. This was the 100th. They didn't have a bad team. They had bad information and no map. And notice what they still don't have 35 minutes into the fire. A way to just stop. No kill switch means your only tools are guesses applied to a live system in production with the meter running. Around 10:15, Knight finally does the only thing left. They pull SMARS out of the market entirely. Rack by rack, the routing engine goes silent. The firm goes dark. 45 minutes after the bell, the damage is on the books. $3.5 billion long across 80 stocks and $3.15 billion short across 74 more. $6.65 billion of positions they never meant to hold. An accidental bet bigger than the company itself, assembled, piece by piece, by a wild loop. And here's the detail that decided Knight's fate. The exchange couldn't just undo it. Under the rules, trades only got canceled in 6 of those 154 stocks, the ones that had moved more than 30%. The other 148? Real trades. Knight owned every single one. Unwinding that mountain, it cost over $460 million. And here's the thing. Knight only had about $365 million in cash. Do that math. The company was dead. It just hadn't stopped moving yet. So who fat-fingered it? Here's the uncomfortable answer. Nobody. Every keystroke that morning did exactly what it was told. This wasn't a typo story. It was a system story. You might think the villain is the technician who missed a server. The SEC didn't think so, and neither should you. One unchecked manual step failing is not a surprise. It's a certainty given enough deploys. The surprise is everything that was waiting behind it. Look at the chain. Layer 1. Dead code left callable in production for 8 years. Power peg wasn't in a museum. It was compiled into every running binary, one branch away from execution. Deleting it was always someone's someday task, and someday has no deadline. Layer 2. A recycled flag. The same bit meaning 2 different things depending on which binary reads it. That's not a convenience. That's a loaded ambiguity, shipped into a fleet where you cannot guarantee every binary is the same. There's a name for the safe version of this. Add a new flag, retire the old one. Never let one signal carry 2 meanings across a version boundary. It costs a code review comment. Knight paid $460 million for skipping it. Layer 3. A safety check relocated in 2005, with no retest of the code path it used to protect. The gun lost its safety during a cleanup, and the cleanup passed because nobody thought a dead feature needed tests. Layer 4. A manual deploy with no verification step. No checklist, no second technician, no automated comparison of what's actually running against what should be. 1 human, 8 machines, 0 nets. The SEC notes it plainly. No written procedures required a review. Layer 5. Alerts that weren't alerts. The system was screaming before the market even opened, into a mailbox nobody was expected to watch. 97 times. We're coming back to that. 5 layers. 5 different years. 5 different teams, probably. Any single one fixed, and August 1st, 2012 is the most boring Wednesday in Jersey City. That's the real lesson, and it's the same one from every great engineering disaster. Catastrophes don't have a cause. They have an alignment. And here's the uncomfortable bit. Your codebase almost certainly has a power peg. Mine too. Some function nobody calls, behind some flag nobody sets, guarded by a test nobody ever wrote. The question isn't whether the ghost exists. It's how many layers stand between the ghost and a live trigger. Count them sometime. If the answer is one manual step performed by one tired human, you're not running a system. You're running a countdown. The market's verdict was immediate. Knight's own stock lost about 75% of its value in 2 days. A firm that had spent 17 years becoming the beating heart of American retail trading was suddenly worth a fraction of itself, shopping for a savior before Monday. The savior arrived that weekend, and it came at a price. Through the next 72 hours, Knight's bankers called everyone. By Monday morning, a group of investors led by Jefferies, with Blackstone, TD Ameritrade, Stifel, Stevens, and a rival market maker called Getco, injected $400 million into the wreck. The deal converted to roughly 73% of the company. Existing shareholders kept the scraps. Knight survived as a guest in its own house. Within a year, that rival Getco bought the whole thing. The Knight name effectively disappeared into KCG Holdings. In 2017, Virtu swallowed what was left. 3 logos on one door in 5 years. 17 years to build. 45 minutes to lose the steering wheel. The regulators came too. The SEC fined Knight $12 million, the first ever enforcement of the market access rule. The rule that says, in plain terms, if your machines can touch the market, you must have controls worthy of that access. 12 million sounds small next to 460, but the order that came with it is why we know this story at all. Every detail in this video, the 8th server, the 2005 refactor, the recycled flag, comes from that public document. It reads like a horror screenplay written by a lawyer. And quietly, one of the most humane details in the whole story, the technician who missed the server reportedly kept their job. The management chain above did not survive the post-mortem era. That tells you how the industry read this, not as one person's mistake, but as an organization that let a mistake become unstoppable. The fixes that followed are now just how serious trading firms work. Hard kill switches, tested like fire drills. Automated deployment with verification, not hope. Fleet-wide checks that every server runs the same build. Dead code treated as a liability, not a keepsake. And alert channels that a named human actually owns. If you build software that touches money, medicine, or machines, this list is your inheritance from Knight Capital, paid for in full in someone else's cash. If you enjoy engineering forensics like this, subscribe. We break down one real story every week in this same depth. And don't leave yet, because I promised you 97 emails, and they're the perfect ending. Rewind to 8:01 a.m., 89 minutes before the opening bell. The trading floor is quiet. The market is closed. The disaster is, at this exact moment, entirely preventable. Some early orders trickle into SMARs for pre-market processing. Routine stuff. But a few of them carry the new flag, and the router sprays them across all 8 servers, including Server 8. Server 8 tries to do its 2003 thing. Something downstream rejects the result, and Knight's own infrastructure notices. An internal system starts generating automated messages, each one referencing SMARs, and each one naming the error in plain text. Power peg disabled. 97 of those emails went out to a whole group of Knight personnel before the market even opened. The name of the dead feature in the subject line, 97 times, while there was still an hour and a half to pull one server out of rotation. So why did nobody act? Well, because those emails were never designed as alerts. They were routine system chatter, the kind of automated noise every engineer learns to filter, skim, and archive without reading. There was no pager, no dashboard going red, no rule that said, if this specific string appears, wake somebody up. Just 97 identical messages, politely joining a folder with 10,000 older siblings. The signal was perfect. The channel was dead. A warning nobody treats as a warning is just spam with good timing. Be honest, how many unread automated notifications are in your inbox right now? One of them might be your power peg. Statistically, it's noise. That's exactly why it works. The SEC's dry conclusion is the one that stays with me. These messages provided an opportunity to identify and fix the issue before the market opened. The opportunity expired at 9:30. 45 minutes of chaos for $160 million, a 17-year-old company gone, and the whole thing was sitting in an inbox at 8:01, politely announcing itself. 97 times. The tower is still there, across the river. Different logo on the door now. The market at Fed never even paused. August 2nd was just another trading day. That's the strangest part of software disasters. The systems move on instantly. Only the lessons stay, for whoever is willing to read the report. Somewhere in your stack, right now, a flag is waiting to mean two things at once. A checklist is waiting to be written. An alert is waiting for an owner. Find them before they find traffic. More stories like this every week. If this one earned it, subscribe. Thanks for watching.